is our new math word wall word, and it is numerator. When we say numerator, because it's the top part of the fraction, the top part, not fart. All right, the top part of a fraction. We're going to say numerator really high. I also want you to take a peek at these little blinders. They look like horse blinders. Anyway, a numerator is what we call the top part of the fraction, and a numerator is how many parts we're focusing on. So in this case, you can see we're focusing on 2 parts, meaning the pepperoni. Now, it could be the 2 eaten parts, so that's why you have to look at the question. But anyway, that is a numerator.
Hey, what is up? All right, so I can't be here today, but I can still teach you gestures for your new word wall words. Do you know what this spells? Wow. This is mom. Anyway, all right, back to the point. So, here you go. You already saw the poster for numerator. Here is the gestures. You ready? Mirror with words. Good job. If you didn't do it, do it. Mirror with words. A numerator is how many parts we're focusing on. A numerator is how many parts we're focusing on. A numerator is how many parts we're focusing on. All right, and stop. All right, so this focusing on part, I don't know if you've seen blinders on a horse, those black blinders, like are on the picture. But the reason this is sign language for focus is sort of like horse blinders. They focus you on something. So when you have a fraction with 2 shaded out of 4, the part you're focusing on is the shaded, but it could be the unshaded. All right, ready? Recite it with me. Ready? Recite. A numerator. High voice. A numerator is how many parts we're focusing on. Good job. All right, so that's numerator. Okay, it could be the shaded part, the unshaded part, the amount of wrapped presents versus unwrapped. It's just what you're focusing on, and that's that top part of the fraction.
This is the denominator, and we say it very low, like the Terminator. Denominator. Anyway, a denominator is this bottom number here in a fraction, and a denominator is how many equal parts are in the whole. And I want you to understand that's one whole. Even if there were a whole bunch of them, this number tells us how many parts are in one of the wholes, also meaning what's the size. And you can see that these are in 4th size pieces. There could be a ton of them, but the size pieces are in 4ths. So we determine the denominator by noticing how many equal parts are in one of the wholes. And so that number goes here. So you can see 4.
All right, so you saw the denominator poster. Time to do your gestures for it. So here we go. Ready? Mirror with words. A denominator. Lower. A denominator. Here's something for you. Hello. A denominator. All right, enough of that. All right, ready? Mirror with words. A denominator is how many equal parts in the whole. How many equal parts in the whole. A denominator is how many equal parts in the whole. A denominator is how many equal parts in the whole. All right, and stop. So understand that a denominator is just how many parts are in one of the wholes. Even if there's a whole bunch of them, okay, meaning one whole, you just look at the size of the piece. How many are in one whole? That's also like the size of the pieces. All right, so ready? We're going to recite it all together. Ready? Recite! A denominator is how many equal parts in the whole. Now let's do it a lot faster. Ready, set, go. A denominator is how many equal parts in the whole. All right, nice job. That's denominator. We'll practice that more later. All right, so now I want you to go back to your own iPad, get your earbuds in, and go ahead and work on the next part of your packet while following along with me. That way you can pause and do things at your own pace. Ooh, I'm hungry. All right, all better. All right, so go ahead. You're on your own now.
How to create a model or a visual of halves or thirds along with all of their equivalent fractions. So I'll explain more about that as we go. So remember, you can pause as you need, but go ahead and get down what I have on here, and you can just follow along at your own pace. All right, so what is a numerator? A numerator, so we'll write this, is how many parts we're focusing on. A numerator is how many parts we're focusing on. A denominator. A denominator is how many equal parts in a, meaning one, in a whole. A denominator is how many equal parts in a whole. What fractions are equivalent? I want you to underline equi, and underneath write EQUAL, so you can see that they're similar. Equivalent means the same. So let's just start off with writing 1/2, just like I did, this sort of vertical version. And then we're going to go down, we're actually going to go ahead and draw it. So you're going to have to look and sort of find the middle of the rectangle, so you can see right there, and you're going to have to do one of those eyeballing things. Like, are you a kid who, when you look at a wall, you can tell if that picture is a little bit crooked and it drives you nuts? Yeah, that's me. All right, so let's go ahead and draw straight down the middle. Okay, you want it to be as straight as possible, so you're really representing 1/2. Okay, all right, now what I want you to do is go ahead and just do what I call a quick shade. It has to be fast. So you're just going to sort of do the outside edges, and we're going to go ahead and shade 1/2. And then you can quick shade the middle. Okay, shouldn't take much longer than what I just did. All right, so we just created 1/2 because the numerator, 1, is how many shaded, and the 2, the denominator, are how many equal parts are in this whole. Okay, all right, so now what we're going to do is we're actually going to double each piece. Okay, now you notice the language I say. So I want you up above here to write ×2 to the denominator and ×2 to the numerator. We're going to do it to both parts and put equals. Okay, so what we're going to do is double each piece. Okay, so let's go ahead and create another 1/2 down here as carefully as you can, and shade in the 1/2. Okay, and now we're going to double each piece. And when I say double each piece, I mean we're going to cut this one so that we have 2 now. We doubled the piece, but we have to do it equally with everything. So essentially we just drew a straight line through. So we just doubled all these pieces. So now, instead of just 2 equal parts in the whole, I have 4. Okay? Instead of 2 shaded, instead of 1 shaded, I have 2. And so you can see that I now have 1 times 2 is 2, and 2 times 2 is 4. So they are exactly the same. Okay? Something new I want to talk about also. Maybe some of you know what this means. 2 out of 2. If I have 2 out of 2 shaded, 2 out of 2 is the same thing as, do you know in your head? 1 whole. Okay, now you don't need to write that. I just want you to think about that and see. So if I'm multiplying both parts by 2 over 2, or 1 whole, I'm essentially just multiplying by 1. And we know the identity, the one-dentity property, means if you multiply by 1, or 1 whole, that you're not changing anything at all. And so that's why 2/4 is equivalent to 1/2. Okay? So let's go ahead and do this one more time. So start with making a half. And I don't want you to ever just go instantly to fourths. You need to make a half and then shade it. All right, now let's go ahead and double each piece. Double, double. And you can see we have our 2/4. Now let's go ahead and double all of those pieces. So go back up to your fraction and let's multiply by 1 whole. Okay, but we're going to double each piece, so 2 over 2. And then put your equal sign. It should be nice and small like mine. Nothing out of the lines. And we can sort of calculate what's going to happen here. So 2 times 2 is 4, and 2 times 4 is 8. So we should end up with 4/8. So you can see 1 shaded out of 2 is half of 2. 2 shaded out of 4 is half of 4. 4 shaded out of 8 is half of 8. These are all half of a new cut up amount. All right, so let's go ahead and officially double each of these parts. So you could go this way, but you start making too tiny of pieces. So I always recommend keeping the pieces as big as possible. Pretend it's like cutting brownies. You don't want a little sliver. You want a nice piece. So double, 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 double. Okay, so now you can see we have 1, 2, 3, 4 that we're focusing on. That's our numerator. And out of 8 equal parts in a whole. So these are all equivalent fractions. We could even do this one more time. Okay, let's go ahead and do it. Cut this one in half. Shade it in. Double each piece. So halves turns into fourths. Double each piece. Fourths double to eighths. And what are eighths going to double to? Da 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 da. You're right. Double, 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 double. If you do this math up above and you multiply both parts by the same number, you get 8 shaded out of 16 equal parts in the whole. They are all exactly the same fraction. Okay? If you look at this, is this piece of a cake any bigger than this piece of a cake? No, not at all. It's just cut up more. We didn't do anything different to it. We just cut it up more. So they are equivalent to each other. Now, I said let's do one more. How many could we actually do? A question you'll be answering tomorrow. How far could I continue with this? something to think about and share later. All right. So one thing before we move on to the circles I want you to see is if someone says, hey, cut something into 16ths, you need to say, all right, I need to start by cutting it in half. And then I'll make fourths, then eighths, then 16ths. And notice it's not times 2. We're not doing 2, 4, 6, 8. We're not counting by 2s. We're multiplying 2 times 2, then 4 times 2, then 8 times 2. So we're doubling each denominator. That's different than counting by 2s. All right, so let's go ahead and move down to your circles now. Okay, so these ones are pretty easy. It's the same concept. Let's just do a couple. So go ahead and cut your circle in half. This is like when you send in cookie cakes without cutting it for the teachers and say, cut it into 21 pieces, please. Thanks a lot. It's really fun to cut 21 slices of a circle. I should make you do that right now. See how fun it is. That's okay. I'll cut it in half. I'll eat half and give you the rest. You can all pull off a piece, something like that. All right, so we cut it in half. Let's go ahead and shade our half. And if I said, turn this into eighths, your brain should be going, okay, I need to cut it in half first. All right, go ahead and pause this and turn this into eighths by creating an equivalent fraction and continue doubling each piece until you have 8 equal parts in a whole. We're going to change the denominator. Go ahead and hit pause, and then you can unpause and see if you did it correctly. All right, so we double each piece, and we made fourths, and then we're going to double each piece again, like this. And you can see we still have 4 out of 8 shaded. Okay, so that's a circle. Go ahead and turn to your next page, and we're going to talk about cutting things in thirds. All right, so make sure you are now on the page that says 1/3 right here. And we are going to go ahead and write these in a second time because that'll help get it into your head. So go ahead and hit pause, and you can write in a numerator is how many parts we're focusing on. A denominator is how many equal parts in a whole. And then go ahead and hit unpause and when you're ready, and we'll continue. So now we're going to address equivalent to 1/3. So underline equi and write EQUAL. And we're going to start off by writing the fraction 1 out of 3, which is the same thing as 1 divided by 3 and 1/3. All right, so here's how you make thirds. I need you to visualize this. Here's the center of the rectangle. And what you're going to say is a little bit to the left, and you're going to draw a line, and then you're going to go back to center and say a little to the right. So if I ask you over the next couple of days, how do we cut something, a rectangle, into thirds, you say find the middle, then go a little to the left, a little to the right. All right, so you're going to have to do some eyeballing, and if it doesn't look equal, you need to erase it. So here's the middle. I'm going to go a little to the left, about to here, and I'm going to go a little to the right, about to here. And you can see these sizes should be pretty equal. If they're not, erase it and do it again. Sometimes when people do it, they accidentally do the lines a little bit too short together, and you'll see this giant part here. So when you do it, make sure you'll start to get used to eyeballing thirds and make sure they're pretty equal with each other. All right, once you do, then we'll go ahead and same thing. We're going to shade one part because that's what we're focusing on. Don't go out of the lines, please. So go around the edges and then fill in the inside. All right, so there's 1/3, one that we're focusing on out of 3 equal parts in the whole. Let's go ahead and double each piece by multiplying both parts by the same number, which is 2. We're going to double each piece. And remember, 2 over 2 is a whole. So we're basically multiplying by 1, which is why we're not changing anything. We're just cutting it up more. All right, so let's double each piece. Double, double, double. Okay, and again, don't go down, because look, we're making these small strips. And if we were doing brownies, that wouldn't be a good size to eat. So keep them nice rectangle-sized pieces that are more squarish looking. All right, so now we've created an equivalent fraction. So 1/3, the next equivalent fraction is 2 times 1 is 2, and 3 times 2 is 6. And so we have 2/6, or 2 out of 6. If you count by 2s, 2, 4, 6, you can see we have thirds. Okay. All right, so now let's go ahead and double each piece again. Okay, so what I want you to do is come down here and let's make thirds again. So find the middle, and we all say a little bit to the left, a little bit to the right. So draw your little line segments. So there's our third. Go ahead and shade off a third with some little quick scribble. And let's go ahead and make our 6th by doubling each piece like we did. And now we will make the next equivalent fraction and multiply both parts by the same number, which is 2 and 2. Okay, so we're going to double these pieces. And this, I don't know if it really matters if you go vertical or horizontal. They're both sort of strip looking. Double, 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 double. All right, so what did we make? What is our denominator? 6 times 2 is 12. 2 times 2 is 4. So 4/12 is equivalent, equal, the same as 2/6 and 1/3. Go back up here and let's go ahead. Look how it's a little bit hard to see. Let's circle our actual fractions so that we can see the fractions and we can see the work that we did. All right, so if we continued, what would we get next if we doubled the 12ths, the 4/12ths? I want to see what you would do, and then you can peek at your partners in a little bit. Go ahead and double this a couple more times and see what happens. So let's go ahead and do this a couple more times. So double each piece, show the math work, circle the fraction you get. You don't need to draw it, but let's just see if you can create 2 more equivalent fractions that'll go here and here. And then you can take a peek at your partner when you're done. Okay? Go ahead and pause and do that, and then we'll take a look at the circles. All right, so if you did that correctly, here is what you would get. Equivalent to 1/3 is 2/6 and 4/12 and 8/24 doubled to 16/48. Now draw 16/48. I'm just kidding. That would be super annoying. All right, so, but this is exactly the same fraction as this. Okay, 16 is 1/3 of 48, just like 1 is 1/3 of 3. So you can see the connection between them all. All right, go ahead down to the circles now. So this gets a little trickier. Okay, so you may have to do some erasing here if it doesn't quite look right, and we'll be around to take a peek and make sure you're doing this correctly. So really take your time with this. All right, what we're going to do to make thirds on a circle is find the center. So you're really going to have to eyeball this correctly and just put a dot. Okay? Something that you can sort of think about is this dot should be right in the center of almost like a scope, like crosshairs. Okay, so that's where that dot should be. So if that helps you visualize it by putting your pencil like that in the air to think about where it needs to be, do that. All right, so here's what you're going to do. You're going to start by going straight down like this. And now we're going to do a Y, but that Y is going to be really spread out like this. It's not going to be a normal Y. So it's going to go sort of out like this. And you can see then that these pieces are really close. And if I'm being really picky, this piece looks a little bit too big, so I should probably adjust it by making my Y a little skinnier on top. That looks better, at least better than before. So just make it as close as possible. I want you to be picky about it. So we have thirds because there is one shaded out of 3 equal parts, which also means that the size of the pieces are thirds. All right, so there's our thirds. Let's go ahead and make thirds again. Find your dot in the center. That's the most important part. If it's off, your whole thing's off. Straight down, and then go ahead and do your spread out Y. Okay, and I'm actually going to adjust this just a little bit. There we go. I like that better. All right. And then go ahead and shade in your 1/3. And now, just like before, we're going to double each piece. So 1/3 doubled, okay, making an equivalent fraction. If we start at the center, and here's another tip for this one. Find the center and put a dot. Find the center, put a dot. Find the center, put a dot. Okay, so I really recommend you use a strategy to double each piece, and then all you have to do is connect the dots, and it helps you keep track of what you cut so far. Okay, all right, let's make another one. So we can do it right here. Find your center dot. Oops, it's not center. Okay, I want you to be picky. Draw straight down. Make your spread out Y. If it's not straight, then do it again. I know Jacob's probably going to be using his ruler here, his straight edge. All right. You were, weren't you, Jacob? All right. Go ahead and shade 1/3 again. Now let's go ahead and double each piece. So we're creating our equivalent fractions. We already did 1/3. And then our next equivalent is 2/6, and now we're going to double each part and make 4/12. So use that strategy I said and put a little dot in the center of each of those. So we're doubling each part to make 2/6. Okay, now go around again and put your dot in the center of these ones so we can double each piece. And then go ahead and connect the dots. It helps you keep track of what you've done and haven't done, and it also keeps it really neat. Everything needs to go hit right into that center point. Okay, so now you have this pizza. This is actually a typical large pizza cut in 12 slices, so that's how you do it. Okay, all right, so we have 4/12 is equivalent to all of those. Just for fun, go ahead and see if you can do 16ths. Oh, it wouldn't be 16ths. Double each piece. See if you can make 8/24. They're going to be really tiny. This is you cutting a cookie cake for your classmates. Okay, so go ahead and do that. Let's put our dot in the middle. Straight down. Your Y. You're going to have to be really careful here. Shade the same section. 1/3. And here we go. Double, 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 connect, connect, connect. Okay, we have 6. Now we need to go to 12ths. Put your little dots in the centers to double each piece. Times 2, times 2, times 2, times 2. Alright, now's where we get teeny cookie cake slivers. Put your dots in the very center of each one. And here we go. Keep going into the center perfectly. Itty bitty living space. Itty bitty cookie space. Woo! Look at that. Aren't you craving one of those slices? At least you can lick the icing. All right, so this is how you create equivalent fractions and represent them by drawing a picture. Okay, so the big thing I want you to take away here is if someone says, hey, I want you to show something that's in 12ths, you need to say, do I start off by cutting something in half, or do I start off by cutting it into thirds? And you're going to have to pause and think, okay, halves go halves to fourths to eighths to 16ths. Thirds go from thirds to sixths to 12ths to 24ths and so on. So you're going to have to think ahead. And the one twist is if you get something like cutting something into fifths. And those are just a big pain in the butt. The only thing you want to do if you're cutting something into fifths is literally draw the individual pieces. Something like this. 2, 3, 4, 5. And then you'll have 5 equal pieces in a rectangle. Don't do a circle unless someone's making you do a circle. Rectangles are way easier. All right. And then, of course, your fifths would then turn into, that's right, tenths and 20ths and 40ths and so on. So just know if you want to create something where you have to start to do it if you're modeling it and drawing it. All right, nice job. Go ahead and put this away and do a round of extra math into ST Math, please. Nice job. Oh, and also nothing else on this is homework. Your daily CCR is the only homework. The other blank circles were just if we need them. So that's why it says no homework on the top of these pages. You don't need to do anything more with these pages.